Imagine a world where death isn't the ultimate full stop, but merely a comma in the grand sentence of your existence. What if every near miss, every brush with mortality, wasn't a close call, but a quantum divergence? We are about to embark on a journey into a realm of thought so mind-bending, so potentially paradigm-shifting, that it will leave you questioning the very fabric of reality. Consider this. What if you were destined, in a very real, albeit unconventional way, to survive absolutely everything? Not in the sense of eternal youth or divine protection, but through the bizarre and fascinating implications of quantum physics. We're not talking about traditional immortality, the kind sought after by alchemists and emperors for centuries. This is something far stranger, far more intricate, and potentially far more unsettling. This journey will explore the controversial, often debated, and utterly captivating concept of quantum immortality, a theory that suggests your consciousness, your very sense of self, is somehow tethered to a lifeline that stretches across the vast ocean of possible realities. A lifeline that ensures, from your subjective point of view, you always find a way to keep going. Think about it for a moment. Every decision you make, every chance encounter, every moment of crisis presents a fork in the road, a point where reality could unfold in countless different ways. In most of these scenarios, perhaps the vast majority, your story ends. But what if, in at least one of those branching paths, you survive? And what if your consciousness, your awareness, is drawn inexorably towards that surviving timeline? This isn't science fiction. Well, not entirely. It's a thought experiment rooted in the most perplexing and revolutionary branch of physics ever conceived, quantum mechanics. It is a concept that touches upon profound questions about the nature of consciousness, the structure of the universe, and ultimately, your place within it. Get ready to challenge your assumptions about life, death, and everything in between. Prepare to dive deep into the quantum rabbit hole, where the rules of reality are not quite what they seem. You might just discover that the question isn't whether you can survive, but whether, on some fundamental level, you already are. But before we can even begin to contemplate the possibility of sidestepping the Grim Reaper, we need to venture into a realm that makes even the most seasoned physicists scratch their heads: the quantum world. Forget everything you think you know about how the universe works, because down at the level of atoms and subatomic particles, reality gets, well, downright weird. Imagine a world where a single grain of sand could be in two places at once, not just hidden under two different dunes, but truly existing in both locations simultaneously. It sounds like something out of a science fiction novel, but this is precisely what happens with quantum particles. They can exist in multiple states, a phenomenon known as superposition until we try to observe them. It's like they're playing a cosmic game of hide-and-seek, only they're hiding in all possible locations at the same time. This challenges our classical understanding of the universe, the one governed by Isaac Newton's laws of motion, where everything has a definite position and velocity. In the quantum world, however, things are probabilistic, governed by chance and uncertainty. It is a realm where location is described by probability waves, not fixed points. Think of it like this. Instead of knowing exactly where a car is on a highway, you only know the probability of it being within a certain stretch of road. So how does this relate to our quest for quantum immortality? Well, this foundational knowledge is absolutely key. Because if particles can exist in multiple states simultaneously, then perhaps, just perhaps, so can we. Or more accurately, perhaps so can our consciousness. Grasping these fundamental principles of quantum mechanics is the first step in unlocking the secrets of this strange and unsettling thought experiment. It's about more than just understanding the science. It is about opening our minds to the possibility that reality itself might be far more fluid, more malleable, and more multifaceted than we ever imagined. This opens up the door to a universe of infinite potential. Perhaps the secrets we are looking for lie within. But before we delve deeper, let's explore a famous thought experiment that perfectly illustrates the counterintuitive nature of quantum states. So particles can be in two places at once, but what about something a little more alive? Something furry, perhaps? This brings us to one of the most famous and arguably unsettling thought experiments in all of physics: Schrödinger's cat. Imagine a sealed box. Inside there's a cat, of course. Also, there's a fiendishly clever device consisting of a radioactive atom, a Geiger counter, a hammer, and a vial of poisonous gas. Now, here's the catch. There's a 50-50 chance that the radioactive atom will decay within the next hour. If it does, the Geiger counter detects it, triggering the hammer, which smashes the vial, releasing the poison, and, well, you can guess what happens to the cat. But here's the quantum twist. Until we open the box and observe what's happening, the radioactive atom exists in a state of superposition. It's both decayed and not decayed at the same time. This means, according to the rules of quantum mechanics, the cat is also in a state of superposition. It's both alive and dead simultaneously. A rather unfortunate predicament for our feline friend, wouldn't you agree? This isn't just some abstract mathematical concept. It's a stark illustration of the bizarreness that reigns supreme in the quantum realm. It forces us to confront the uncomfortable question, what does it even mean for something to be in two states at once? Is the cat half alive, half dead? Is it some kind of quantum zombie? The crucial point is that the cat's fate is linked to a quantum event. The decay of the atom. A coin flip at the atomic level that determines the cat's very existence. And until we peek inside the box, reality remains blurred, a mixture of possibilities. It is like a deck of cards, held tightly in your hand, containing both the ace of spades and the two of clubs. Until you lay a card on the table, the possibilities merge. Now, some might argue that this is just a thought experiment, a convenient way to illustrate the weirdness of quantum mechanics. But it highlights a profound problem. It exposes the limitations of our everyday intuition when applied to the subatomic world. It challenges our classical understanding of cause and effect, of objective reality. Erwin Schrödinger, the Austrian physicist who devised this experiment in 1935, didn't actually believe that cats could exist in such a paradoxical state. He created this thought experiment precisely to highlight the absurdity of applying quantum mechanics to macroscopic objects. He intended it as a critique of the Copenhagen interpretation, one of the dominant interpretations of quantum mechanics, which suggests that observation plays a fundamental role in collapsing the wave function, the mathematical description of a quantum system. Schrödinger thought it was ridiculous that simply looking at something could change its state of being. But whether he liked it or not, Schrödinger's cat has become a central icon in quantum physics. It represents the inherent uncertainty and the mind-bending nature of reality at its most fundamental level. It is a constant reminder that the universe is not always as it seems. So what does the cat's fate have to do with quantum immortality? Well, consider this. If the cat can be in a superposition of alive and dead states until observed, could the same principle apply to us in moments of life-threatening situations? If reality branches every time a quantum event occurs, then could there be a universe where the cat lives and another where it dies? And if so, which universe would you experience? This is where the plot really thickens, leading us to contemplate an even more radical idea: the existence of infinite Earths, each branching off from every quantum decision ever made. So our quantum feline friend might be both alive and dead, a truly bizarre concept. But what if this isn't just confined to tiny boxes and hypothetical scenarios? What if this branching of possibilities extends to every single quantum event, every single decision, every single moment in time? This brings us to a truly mind-bending idea: the many worlds. Interpretation, also known as MWI. It is a radical theory proposed by the American physicist Hugh Everett III in 1957. A concept so profound, so unsettling, that it suggests our universe isn't the only universe, but merely one universe among an infinite, ever-expanding multiverse. Think of it like this. Imagine a vast cosmic tree, its trunk representing the moment of the Big Bang. As time moves forward, the tree branches out again and again and again. Each branch represents a different possible outcome of a quantum event. Every time a quantum decision is made, the universe splits, creating a new parallel reality. In one universe, you might have chosen coffee this morning. In another, you opted for tea. In yet another, a meteor struck your city, altering the course of your life forever. The possibilities are quite literally endless. And according to the many worlds interpretation, all of these possibilities actually happen. This isn't some philosophical flight of fancy. Everett's many worlds interpretation is a serious attempt to grapple with the complexities of quantum mechanics. It offers a potential solution to the measurement problem, the question of how quantum superposition collapses into a single definite state when we observe it. According to MWI, superposition doesn't collapse. Instead, the universe splits, with each possible outcome playing out in its own separate reality. There's no collapse, no wave function reduction, just constant branching, an endless proliferation of universes, each subtly or dramatically different from the last. Now I know what you might be thinking. This sounds utterly insane. Infinite universes? Countless versions of you? It's the stuff of science fiction, isn't it? Well, yes, it is. The many worlds interpretation has certainly inspired its fair share of science fiction stories, but it's also a legitimate scientific theory, one that's taken seriously by a number of physicists. One of the most compelling aspects of MWI is that it eliminates the need for a special role for the observer. In some interpretations of quantum mechanics, consciousness is believed to play a key role in collapsing the wave function. But in MWI, there's no collapse, so consciousness doesn't need to be involved. All possible outcomes simply play out in their respective universes. The implications are staggering. If MWI is correct, then there's a universe out there where the dinosaurs never went extinct, where the Roman Empire never fell, where John Lennon is still alive, where you made a different choice at a crucial moment in your life and are living a completely different existence. It's a mind-boggling concept, one that challenges our very notions of reality and identity. But how can we possibly test such a theory? How can we prove that these parallel universes actually exist? That's the million-dollar question, or perhaps the multi-billion universe question. Scientists are exploring various avenues, looking for subtle clues, echoes from these other realities. From analyzing the cosmic microwave background radiation to searching for anomalies in quantum experiments, the quest to find evidence for the multiverse is on. But regardless of whether or not we can ever definitively prove the existence of these infinite Earths, the many worlds interpretation remains a powerful and compelling idea. It forces us to confront the deepest questions about the nature of reality, consciousness, and our place in the cosmos. It also forms the bedrock upon which the concept of quantum immortality is built. Because if every possible outcome actually happens, then perhaps, just perhaps, there's always a universe where you survive, no matter how improbable it may seem. But before we get to that, let's delve into an even more chilling thought experiment, one that directly leads to the idea of quantum immortality. Prepare yourself for the quantum suicide gamble. Imagine, if you will, a game of Russian roulette, but instead of a revolver, the fate of the player hangs on the whims of a quantum event. This isn't some back-alley gamble with desperate stakes. This is a thought experiment of the most profound and chilling kind, a test designed to probe the very limits of survival itself. Welcome to the quantum suicide gamble. Devised by theoretical physicist Max Tegmark in 1997, this isn't an experiment you'd actually want to try at home, or anywhere else for that matter. It's a purely theoretical construct, a dark and unsettling exploration of the implications of the many worlds interpretation. It's a challenge to our fundamental understanding of reality and a precursor to the even more audacious idea of quantum immortality. So, how does this deadly game work? Picture this. A device is set up, one link to a quantum process, say the spin of an electron. Depending on the outcome of the quantum measurement, the device will either do nothing or it will instantly kill the participant. Let's say if the electron's spin is up, nothing happens. Nothing. But if the spin is down, a mechanism is triggered, releasing a lethal dose of poison, or perhaps even firing a gun aimed directly at the participant's head. Now, from an outside observer's perspective, this experiment is straightforward and undeniably grim. Half the time the participant will survive, and half the time they'll meet a rather abrupt end. Simple probability. But what about the participant's own experience? Here's where the many worlds interpretation throws a wrench into the works. According to MWI, every time the quantum measurement is made, the universe splits. In one branch, the electron's spin is up, the device doesn't activate, and the participant survives. In the other branch, the electron's spin is down, the device triggers, and the participant dies. But here's the crucial question. Which branch does the participant experience? If the many worlds interpretation is correct, then the participant would only experience the branches where they survive. In the timeline where the device kills them, their consciousness ceases to exist. There's no more subjective experience. But in the timeline where they survive, their consciousness continues, completely unaware of the other branch where they perished. From the participant's perspective, the device clicks harmlessly every single time. They pull the trigger, or whatever the activation method may be, and they live to see another day, again and again, defying the odds with each iteration. It's as if they're living in a universe that's been meticulously curated to ensure their survival. Think of it as if you're navigating a maze, and every time you come to a fork in the road, the path you don't take vanishes from your awareness. You only experience the path that leads you forward, regardless of how many dead ends there might be in other, now inaccessible realities. This is the chilling logic at the heart of the quantum suicide thought experiment. It suggests that if MWI is true, then our subjective experience is inherently biased towards survival. We only experience the realities where we continue to exist, no matter how improbable those realities might be. It's a difficult concept to wrap your head around, isn't it? It challenges our most basic assumptions about death and reality. It implies that from our own point of view, we might be far more resilient than we ever imagined. This experiment, of course, has never been conducted, and for very good reason. The ethical implications are staggering, but it serves as a powerful tool for exploring the bizarre and unsettling consequences of quantum mechanics. What does this mean for our understanding of existence? Does it suggest that consciousness plays a more fundamental role in shaping reality than we previously thought? Is there a cosmic safety net that ensures our survival, at least from our own perspective? These are the questions that quantum suicide forces us to confront. But quantum suicide is just the opening gambit. It's a stepping stone to an even more audacious idea, one that suggests that you, yes you, might be destined to survive absolutely anything from asteroid impacts to nuclear holocausts. It's time to take the leap into the realm of quantum immortality. So, you've survived the quantum suicide gamble. A chilling prospect indeed. But what if that inherent bias towards survival extends beyond the confines of a single contrived experiment? What if it's a fundamental feature of the universe, a quantum cheat code that allows you to dodge the ultimate fate, not just once, but every single time? This brings us to the very heart of the matter, the core concept of quantum immortality. It is the idea that your conscious experience will always, inevitably, follow the path where you continue to exist. Think of it as a cosmic navigation system, guiding your awareness through the labyrinth of branching realities. In every moment of crisis, every near-death experience, the universe splits into countless possibilities. In most of those realities, you cease to exist, your story ends, but in at least one reality, you survive. And according to the quantum immortality hypothesis, that's the reality you will experience. It sounds like science fiction, doesn't it? A plot device ripped straight from the pages of a Philip K. Dick novel. But the implications are profound. If this is true, then from your own subjective point of view, you are effectively immortal. Let's be clear, this doesn't mean you'll become some kind of indestructible superhero impervious to all harm. It doesn't mean you'll live forever in perfect health, untouched by the ravages of time. The copies of you in other timelines will still perish. They will succumb to accidents, diseases, old age. But your consciousness, your sense of self will always find a way to persist, jumping to the next surviving branch. Imagine standing on the edge of a cliff. You stumble, you fall. In countless universes, you plummet to your doom. But in at least one universe, a sudden gust of wind catches you, or a sturdy branch breaks your fall, or a flock of pigeons somehow manages to lift you to safety. It sounds absurd, I know, but the point is, there's always a possibility of survival, no matter how improbable. And according to quantum immortality, that's the possibility you'll experience. Consider a skydiver whose parachute fails to open. In most realities, the result is catastrophic. But in one reality, a freak atmospheric anomaly slows their descent just enough for them to survive the impact. Or perhaps they land in a conveniently placed haystack, defying all odds. From the outside, it looks like a miracle, but from the skydiver's perspective, it's just another day. They may not even realize how close they came to oblivion. They simply continue on, blissfully unaware of the countless versions of themselves that met a far grimmer fate. This is the crux of the quantum immortality argument. It's not about avoiding death altogether. It's about shifting your perspective, recognizing that death, from your own subjective point of view, might be an illusion. A doorway to another reality where you continue to exist. But how can this be? How can consciousness navigate these branching timelines? What is it about our awareness that allows it to sidestep the Grim Reaper again and again? These are questions that have plagued physicists and philosophers for decades. Some argue that consciousness itself plays a fundamental role in shaping reality, that the act of observation, of being aware, somehow influences the quantum wave function, forcing it to collapse into a state that ensures our survival. It is a controversial idea, one that borders on the mystical, but it highlights the profound mystery of consciousness and its relationship to the physical world. Others believe that quantum immortality is simply a consequence of the many worlds interpretation, a statistical inevitability. With infinite universes branching off every second, there are bound to be some where you survive no matter how unlikely. And since your consciousness can only exist in the universes where you are alive, you will always experience those surviving branches. It's a numbers game, a cosmic lottery where you are always guaranteed to win, at least from your own perspective. Of course, there are plenty of skeptics who dismiss quantum immortality as nothing more than a philosophical curiosity, a thought experiment with no basis in reality. They argue that the many worlds interpretation is itself unproven, and that even if it is correct, there's no guarantee that consciousness can actually jump between timelines. They point out that the odds of surviving some catastrophic event are often infinitesimally small, and that relying on quantum immortality is a recipe for disaster. After all, even if you are destined to survive from your own point of view, there's no guarantee that the surviving timeline will be a pleasant one. You might end up in a post-apocalyptic wasteland, or trapped in a vegetative state, or living a life of constant pain and suffering. Is that really immortality? Is that really survival? It's a question worth pondering as we delve deeper into the implications of this truly mind-bending idea. The universe is a vast and complex place, full of mysteries that continue to elude our understanding. Quantum immortality is just one piece of the puzzle, a tantalizing glimpse into the hidden depths of reality. Whether it's a genuine phenomenon or simply a philosophical construct, it forces us to confront the deepest questions about life, death, and everything in between. But what happens when we scale up the stakes? When we consider not just individual survival, but the fate of entire planets, entire civilizations? Could quantum immortality offer a way to dodge Armageddon, to avert cosmic collisions, and survive the unimaginable? Let's explore the implications for planetary-scale disasters and consider whether survival against impossible odds is guaranteed, at least for the individual observer. The implications are more profound than we could have ever imagined. The universe is a dangerous place. From the silent vacuum of space to the crushing depths of the ocean, threats lurk around every corner. But what if the greatest threat to our existence came not from a microscopic virus or a human conflict, but from something far more massive, far more indifferent? A cosmic collision? Imagine a giant asteroid, kilometers in diameter, hurtling through space, an unstoppable force of rock and metal barreling towards Earth. Scientists detect it, the world watches, and the horrifying realization dawns. This isn't a near miss. This is a planet killer. This is Armageddon. The impact would be catastrophic. Global earthquakes, colossal tsunamis, a firestorm that engulfs continents, and a prolonged impact winter plunging the planet into darkness. Billions would perish. Civilization as we know it would crumble. The very future of humanity hangs in the balance. But in the face of such overwhelming devastation, could quantum immortality offer a glimmer of hope? Could your consciousness, your individual experience, somehow navigate this planetary catastrophe, finding a way to survive even when all seems lost? According to the quantum immortality hypothesis, your subjective experience will always follow the branch of reality where you continue to exist. So, in the face of an asteroid impact, would your consciousness inevitably shift to a timeline where the asteroid misses Earth, or where humanity finds a last-minute solution? Perhaps, in one branching reality, a team of brilliant scientists develops a revolutionary technology, a planetary defense system capable of deflecting the asteroid at the 11th hour. Maybe a group of courageous astronauts launches a desperate mission, detonating a nuclear device that shatters the asteroid into harmless fragments. Or perhaps, in a more subtle scenario, a slight gravitational anomaly, a minuscule fluctuation in the fabric of space-time, alters the asteroid's trajectory just enough to avert disaster. These scenarios might seem far-fetched, bordering on the miraculous, but the quantum immortality argument suggests that if there's even a remote possibility of survival, your consciousness will gravitate towards that possibility, experiencing the reality where humanity and you live to see another day. Think of it this way. The impact event is a quantum fork in the road. In countless universes, Earth is obliterated and humanity is extinguished. But in at least one universe, something, however unlikely, prevents the catastrophe. And that's the universe you will experience. Now you might be wondering, what does this mean for the billions of other people who would perish in those other timelines? It is a difficult question to address. Quantum immortality is a deeply personal and subjective concept. While your consciousness might find a way to survive, the fate of others remains uncertain. The experience would be different depending on the point of view from which you perceive existence. The focus point is only on your personal timeline. It raises profound ethical questions. If you believed you were quantumly immortal, would it change your behavior? Would you be more reckless, more willing to take risks, knowing that, from your own perspective, you'll always survive? Could such a belief lead to a dangerous disregard for the well-being of others? The implications for planetary-scale disasters are both fascinating and unsettling. If quantum immortality is real, does it offer a form of cosmic insurance, a guarantee that at least some conscious observers will always persist, even in the face of the most extreme threats? Perhaps the very existence of consciousness acts as a kind of stabilizing force, subtly influencing the quantum fabric of reality, increasing the odds of survival against seemingly insurmountable odds. The anthropic principle suggests that the universe's constants seem perfectly set for life to exist. Could quantum immortality be an extension of this, ensuring that conscious life persists from its own viewpoint? It's a mind-boggling idea, one that challenges our understanding of probability and the nature of reality itself, but it forces us to confront the deepest questions about our place in the cosmos. In the face of an existential threat, what is the value of individual survival? What are the limits of human resilience? And what role, if any, does consciousness play in shaping the fate of the universe? The asteroid hurtles towards Earth, a symbol of our vulnerability in the vastness of space. The odds of survival seem impossibly slim, but as we delve deeper into the mysteries of quantum mechanics, we begin to wonder, are those odds truly insurmountable? Or does the universe, in its infinite complexity, hold a hidden escape route, a quantum loophole that could allow us to dodge Armageddon and continue our journey through the stars? A route that, from your perspective, has already been taken. Even in the face of a cosmic bullet like a colossal asteroid, the promise of quantum immortality seems to whisper a possibility of survival. But what about a threat far more insidious? A catastrophe born not of cosmic indifference but of human conflict. What if the end came not from the heavens, but from our own hands? Imagine a world teetering on the brink. Decades of simmering tensions, political posturing, and escalating arms races have finally boiled over. Nations stand poised, fingers trembling on the nuclear trigger. Then it happens. A miscalculation. A rogue act, a desperate gamble. The skies erupt in fire. Global thermonuclear war has begun. The scale of destruction is unimaginable. Cities are vaporized in an instant, reduced to ash and radioactive dust. Firestorms rage, consuming everything in their path. The atmosphere is choked with smoke and debris, blotting out the sun and plunging the world into a nuclear winter. Billions perish in the initial blasts, and countless more succumb to radiation poisoning, starvation, and disease. Civilization crumbles, and the remnants of humanity are left to scavenge for survival in a poisoned wasteland. Could quantum immortality offer an escape from this apocalyptic nightmare? Could your consciousness, your individual awareness, somehow navigate through the quantum foam, finding a reality spared from the worst? According to the hypothesis, in countless timelines, you and billions of others are incinerated in the blink of an eye. The world you knew is gone, reduced to a radioactive wasteland. But in at least one timeline, something different happens. Perhaps a technological glitch prevents a missile launch. A crucial leader reconsiders at the last moment, or an unforeseen atmospheric phenomenon weakens the impact of the blasts. It could be a global coordinated effort to disarm all the nuclear arsenals, or just some bombs malfunctioning due to a technical error. In that timeline, the worst is averted. The world still suffers, but it isn't annihilated. Humanity survives, battered and bruised, but not broken. And according to quantum immortality, that is the timeline you will experience. From your subjective perspective, the bombs never fall, or their impact is far less devastating than feared. You find yourself in a world struggling to rebuild, scarred by the near apocalypse, but not consumed by it. You might witness acts of heroism and resilience as communities band together to overcome the unimaginable challenges. Perhaps you find yourself in a bunker deep underground, shielded from the worst of the fallout. Or maybe you are among the lucky few who possess natural immunity to the effects of radiation. However it unfolds, your consciousness persists. But what of the countless other timelines, the ones where the bombs did fall, where billions perished, where civilization collapsed? Does quantum immortality offer any solace in the face of such widespread devastation? The concept doesn't guarantee a pleasant existence. It only suggests that from your own point of view, you will always find a way to continue, however improbable that may seem. You might survive the nuclear holocaust, only to find yourself living in a world ravaged by disease, famine, and endless conflict. Or perhaps you find yourself trapped in a state of perpetual suffering, your body broken, your mind shattered. Surviving the apocalypse does not mean thriving in its aftermath. The potential downsides must be addressed. It requires a consideration of whether the mere continuation of consciousness is truly desirable. Does the quantum immortality hypothesis offer a path towards survival, or simply a means of prolonging our exposure to suffering? The chilling possibility that your awareness navigates through the quantum foam to a reality spared from the worst introduces as many questions as answers. Could such a belief lead to apathy, a dangerous complacency in the face of existential threats? What is the cost of survival in a world where everything you valued has been destroyed? Are we destined to outlive those we hold dear, forever haunted by the ghosts of what could have been? The outbreak of global thermonuclear war presents a challenge to the very notion of quantum immortality. But whether it's a genuine phenomenon or merely a philosophical exercise, the hypothesis urges us to reconsider the value we place on life, the meaning of survival, and the responsibility we hold towards our planet and our fellow human beings. If the possibility exists that every choice creates a new reality, is it incumbent upon us to steer our own reality away from the path of annihilation towards a future of hope and resilience? What steps must we take to ensure our survival is not merely a continuation, but a triumph of the human spirit? Is surviving the unsurvivable truly a victory, or a sentence to bear witness to a broken world? As we grapple with this question, let us consider an equally insidious threat, one that is silent, invisible, and potentially just as devastating as nuclear war: a global pandemic. Can quantum immortality offer a cheat code to outlast even the most lethal contagion? But what happens when the enemy is neither a rogue asteroid nor a nuclear warhead, but something far more insidious, far more pervasive, something that can spread silently, invisibly, and with devastating speed? Imagine a world gripped by a global pandemic, a lethal virus sweeping across continents, leaving a trail of sickness and death in its wake. Hospitals overflow, cities become ghost towns, and the familiar rhythms of life grind to a halt. Governments struggle to contain the spread, scientists race to develop a vaccine, and fear grips the hearts of billions. In a world where a simple cough can be a death sentence, where every human interaction carries the risk of infection, could quantum immortality offer a potential escape route? Could your consciousness somehow navigate this biological minefield, finding a reality where you possess natural immunity, receive a life-saving cure, or simply avoid infection altogether? Consider the Spanish flu pandemic of 1918, a deadly influenza virus that infected 500 million people worldwide and claimed the lives of an estimated 50 million. Or the Black Death of the 14th century, a bubonic plague that decimated Europe, wiping out as much as 60% of the continent's population. History is riddled with examples of deadly contagions that have reshaped societies and altered the course of human history. What if quantum immortality could somehow rewrite your personal history, shielding you from the ravages of such a disease? According to the quantum immortality hypothesis, your subjective experience will always follow the branch of reality where you continue to exist. So, in the face of a global pandemic with near certain mortality, would your awareness always land in a reality where you possess a unique genetic resistance, a pre-existing immunity that renders you impervious to the virus's deadly effects? Perhaps you find yourself in a remote region, isolated from the centers of infection, untouched by the unfolding tragedy. Or maybe you are among the first to receive a newly developed vaccine, a scientific breakthrough that eradicates the disease before it can claim your life. It's tempting to imagine a scenario where you are somehow immune, a beacon of health and resilience in a world of sickness and despair. But quantum immortality doesn't necessarily guarantee a comfortable existence. It only suggests that your consciousness will persist. What if you find yourself in a reality where the virus is less deadly, where the symptoms are milder, where the healthcare system is better equipped to handle the crisis? You might still suffer, you might still experience fear and uncertainty, but you would survive. Perhaps you are quarantined for months, separated from loved ones, your life reduced to a monotonous routine of isolation. Or maybe you contract the virus, experiencing a brief but terrifying illness, only to emerge on the other side, scarred but alive. Quantum immortality might not shield you from the hardships of a pandemic, but it could ensure that you ultimately endure. The renowned physician and poet John Donne famously wrote, "No man is an island, entire of itself. Every man is a piece of the continent, a part of the main." And in the context of a global pandemic, this sentiment resonates with particular force. Our fates are inextricably linked. The health and well-being of each individual is dependent on the health and well-being of the community as a whole. What then are the implications of quantum immortality for our collective response to biological threats? If a significant portion of the population believes they are destined to survive, could it lead to complacency, a disregard for public health measures, and an increased risk of infection for everyone? Or could the belief in quantum immortality inspire hope, a sense of resilience, and a determination to overcome even the most daunting challenges? The answer, of course, is complex and multifaceted. Quantum immortality is not a magic bullet, a guaranteed escape from the dangers of a pandemic. It is a thought experiment, a philosophical exploration of the nature of consciousness and the possibility of survival against all odds. It raises profound questions about our responsibility to ourselves and to others. Perhaps the most important lesson of a global pandemic is the recognition of our shared vulnerability, the understanding that we are all interconnected and that our actions have consequences that ripple far beyond our own individual lives. Quantum immortality, however speculative, can perhaps remind us that the universe is full of probabilities. As a deadly virus sweeps the globe, threatening to rewrite the story of humanity, we are left to ponder. Does quantum immortality offer a path around deadly diseases? Or does the pursuit of individual survival come at the cost of collective well-being? The answer may lie hidden within the intricate dance of quantum probabilities, but what happens when this quest for survival leads to another philosophical question, the nature of consciousness? Even as we envision dodging the chilling grip of a global pandemic, a question lingers, a mystery that underpins the very concept of quantum immortality. What is it, this ephemeral thing we call consciousness? Is it merely a complex chemical reaction within the gray matter of our brains, or something far more profound, something intrinsically linked to the fabric of reality itself? Perhaps it is consciousness that serves as the linchpin, the crucial element that bridges the gap between the quantum realm and our everyday experience. After all, quantum mechanics itself seems to suggest that the act of observation plays a pivotal role in shaping reality. But how can simply looking at something, thinking about something, change its fundamental nature? This is a question that has baffled scientists for generations, leading to some truly mind-bending theories about the nature of existence. Consider the double slit experiment, one of the most iconic demonstrations of quantum weirdness. When electrons are fired at a screen with two slits, they create an interference pattern, behaving as if they are waves passing through both slits simultaneously. But when scientists try to observe which slit each electron passes through, the interference pattern disappears, and the electrons behave as if they are particles, passing through only one slit at a time. It is as if the very act of watching changes the electrons' behavior, forcing them to choose a single path. This raises a profound question. What is so special about observation? Does it require a conscious observer, a sentient being with the capacity for thought and awareness? Or can any form of interaction, any form of measurement, trigger this change in behavior? The answer remains elusive, but many interpretations of quantum mechanics suggest that consciousness does indeed play a crucial role. One such interpretation is the Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s. This view posits that quantum systems exist in a state of superposition, a mixture of all possible states, until they are measured. It is only when an observation is made that the wave function collapses, and the system settles into a single, definite state. According to the Copenhagen interpretation, the observer is not merely a passive witness to reality, but an active participant in its creation. The observer collapses the wave function. This idea is controversial, to say the least. It implies that reality is not fixed and objective, but rather fluid and dependent on consciousness. It suggests that the universe itself might not exist in a definite state until it is observed. But if observation is so crucial, what exactly constitutes an observer? Does it require a human being, or can a machine, a plant, or even a single-celled organism qualify? This has led to some truly radical ideas about the nature of consciousness itself. Panpsychism, for example, is the view that consciousness is not limited to humans or even animals, but is a fundamental property of all matter. According to panpsychism, every particle, every atom, every molecule possesses some degree of consciousness, however rudimentary. The universe, in this view, is not just a collection of inanimate objects, but a vast, interconnected network of conscious entities. Now, this might sound like something out of a science fiction novel, but panpsychism has gained increasing traction in recent years, attracting the attention of physicists, philosophers, and neuroscientists alike. Some argue that it offers a potential solution to the hard problem of consciousness, the challenge of explaining how physical processes in the brain give rise to subjective experience. If consciousness is a fundamental property of matter, then it doesn't need to be explained in terms of complex brain activity. It simply is. It's a fundamental aspect of the universe, just like gravity or electromagnetism. This doesn't mean that every atom is capable of complex thought or emotion, but it does suggest that there is a spectrum of consciousness ranging from the simplest particles to the most sophisticated human minds. But how does all of this relate to quantum immortality? If consciousness plays a role in collapsing the wave function, as some interpretations of quantum mechanics suggest, then it could be the key to navigating the branching timelines of the multiverse. Perhaps it is consciousness that guides us through the labyrinth of possibilities, ensuring that we always end up in the reality where we continue to exist. It is not only the act of observation to collapse the wave function, that consciousness itself is fundamental to the structure of the universe, as many worlds' interpretation might imply. In this view, our minds are not simply passive observers of reality, but active participants in its creation. We are co-creators of our own existence, shaping the universe through our thoughts, our feelings, and our intentions. Of course, these are just speculations, tantalizing glimpses into the unknown. The nature of consciousness remains one of the greatest mysteries in science, a puzzle that has stumped some of the most brilliant minds in history. But as we continue to probe the depths of quantum mechanics, as we explore the intricate workings of the human brain, we may begin to unravel the secrets of consciousness and its role in shaping the reality we experience. However, if it is not linked to survival, could it be argued that the universe is fine-tuned for life and survival? We have explored the tantalizing, if unsettling, possibility that consciousness plays a pivotal role in navigating the quantum realm, perhaps even influencing reality itself. But what if the deck is already stacked in our favor? What if the very fabric of the universe is woven in such a way as to promote life and, by extension, survival? Consider this. The universe as we know it is governed by a set of fundamental constants, numbers that determine the strength of gravity, the mass of elementary particles, the speed of light, and a myriad of other physical properties. These constants are not arbitrary. They are finely tuned, dialed in to an almost unbelievable degree of precision. If even one of these constants were slightly different, the consequences would be catastrophic. Stars wouldn't form, atoms wouldn't bind together, or the universe would collapse in on itself moments after the Big Bang. In short, life as we know it would be impossible. This is the essence of the anthropic principle, the idea that the universe's constants appear perfectly set for life to exist. It's like stumbling upon a complex machine, a cosmic clockwork, and realizing that every gear, every spring, every tiny cog is precisely calibrated to allow for one specific outcome, the emergence of beings capable of observing and contemplating the universe itself. Is this just a cosmic coincidence? Is it the result of pure, blind chance? Or is there something more profound at play? Could it be that the universe is somehow biased towards life, that it's intrinsically designed to foster consciousness and complexity? Some scientists have proposed that our universe is just one of many, perhaps an infinite number, each with its own unique set of physical constants. In most of these universes, the constants are not conducive to life, and they remain barren and lifeless. But in a tiny fraction of these universes, the constants are just right, and life emerges, evolves, and eventually develops consciousness. We, of course, find ourselves in one of those rare, life-friendly universes. This is one possible explanation for the anthropic principle, a way to avoid the implication that the universe was somehow created with us in mind. But what if the connection between the universe and consciousness is even more direct? What if quantum immortality is not just a consequence of the many worlds interpretation, but a fundamental feature of the universe itself? Could it be that the universe is not just fine-tuned for life, but also for the persistence of conscious life? Could it be that quantum immortality is an extension of the anthropic principle, ensuring that conscious life persists from its own subjective viewpoint, regardless of the odds? It's a radical idea, one that pushes the boundaries of our understanding. But it raises some intriguing questions. If the universe favors life, could it also favor survival? Could the laws of physics, at their most fundamental level, be biased towards ensuring the continuation of conscious experience? Perhaps the universe is not a passive stage on which life plays out its drama, but an active participant, a cosmic gardener carefully tending to its most precious creations, conscious beings capable of observing and appreciating its beauty and complexity from our singular point of view. Maybe you might say it is all about perspective. What are the forces at play, the mechanisms that ensure that conscious life continues to exist? Are there hidden laws of physics that we have yet to discover, subtle influences that nudge reality in the direction of survival? Is there some kind of cosmic feedback loop where the existence of consciousness somehow reinforces the conditions that allow it to thrive? The universe's constants are remarkably set for life, and now the big question, does it favor observers? The answer, if there is one, remains elusive, but the very act of asking the question forces us to confront the deepest mysteries about our place in the cosmos and the nature of reality itself. As we explore this thought, maybe we can search for hints of many worlds by observing echoes in reality. The universe, a canvas painted with cosmic grandeur, often operates on scales that defy human comprehension. We've danced with the concept of quantum immortality, a notion that from your perspective survival is the only certainty. But let's slam on the brakes for a moment. Let's introduce a healthy dose of skepticism into this fantastical equation. We are told about probability and just how that can affect how we can and will continue in our multiverse. The big question we must answer is, does subjective awareness really trump objective probability in the long run? The linchpin of quantum immortality hinges on events with astronomically low odds, somehow consistently breaking in your favor. We are talking about probabilities that make winning the lottery look like a sure thing. Imagine flipping a coin not once, not twice, but 1,000 times, and it lands on heads every single time. Possible? Yes. Probable? Statistically laughable. Now, apply that same principle to dodging a speeding bus, surviving a plane crash, or somehow emerging unscathed from a nuclear blast. Each of these scenarios carries its own infinitesimal probability of success. To believe in quantum immortality is to believe that your existence is a constant string of such improbable victories. But how can we reconcile these near-zero chances with the undeniable certainty of our own subjective experience? After all, you are here, listening to this, alive and well. Doesn't that in itself serve as proof that you have already overcome countless potentially fatal scenarios? Perhaps. But it's crucial to differentiate between experiencing a low-probability event and relying on it for survival. Think of it like this. You might drive your car every day for 50 years without ever getting into a serious accident. That doesn't mean you are immune to car accidents. It simply means you have been fortunate, statistically speaking. Quantum immortality proposes something far more radical. It suggests that you are not simply lucky, but rather destined to be lucky. That your consciousness is somehow drawn towards the timelines where you defy the odds and continue to exist. It means you have this invisible luck factor, and that the possibilities that may kill you are no longer valid in your reality. This perspective shift requires a leap of faith, a willingness to abandon our conventional understanding of probability and embrace a reality where subjective experience trumps objective chance. Is it arrogance or ignorance, or maybe is it the universe rooting for us? But here is where the philosophical gears start to grind. What exactly constitutes survival in the context of quantum immortality? Does it mean simply continuing to exist, even in a severely degraded state? Imagine surviving a plane crash only to be left paralyzed in constant pain and trapped in a hospital bed for the rest of your days. You survived, yes, but at what cost? Or what about scenarios where your survival comes at the expense of others? Imagine a bus swerving to avoid hitting you, only to crash into a crowd of pedestrians, killing several people. You survive, but is that truly a victory? These are the uncomfortable questions that quantum immortality forces us to confront. It challenges us to reevaluate our understanding of life, death, and the meaning of existence. Does survival at any cost truly represent a win, or does it simply prolong our exposure to suffering, both our own and that of others? Perhaps the key lies in recognizing that probability, while a powerful tool for understanding the universe, is not the be-all and end-all of existence. Subjective experience, our individual sense of awareness, plays a crucial role in shaping our reality. Think about it. Two people can experience the same event, a concert, for example, and have completely different takeaways. One might rave about the music, the atmosphere, the sheer joy of being there. The other might complain about the noise, the crowds, the overpriced drinks. Which is the true experience? Both, of course. Reality is subjective, filtered through the lens of our individual consciousness. Quantum immortality suggests that this subjective filtering extends even to the most fundamental aspects of our existence, shaping our perception of life and death itself. Whether the statistical probability of a positive outcome is low or high, could it be that our awareness actively shapes the probabilities we experience, subtly influencing the universe in ways we do not yet fully understand? Are we not merely passive observers, but active participants in the unfolding drama of reality? It's a question that echoes down the corridors of physics, philosophy, and the very heart of our own existence. Now, if this experiment does work, how are we to look for proof or support of this in the multiverse? Could this exist in reality, and where might we see them? Quantum immortality, the idea that your consciousness always finds a way to survive, sounds like a cosmic insurance policy. But before we start living recklessly, convinced we are invincible, it is crucial to hear from the skeptics. Because while the many worlds interpretation and quantum immortality offer a tantalizing glimpse into the nature of reality, not all physicists are convinced. One of the major criticisms leveled against the many worlds interpretation is its sheer untestability. How can you prove the existence of parallel universes? How can you interact with them, measure them, or even detect them? For many scientists, the lack of empirical evidence is a deal breaker. Science relies on observation, experimentation, and falsifiability. If a theory cannot be tested, it cannot be proven, and it remains in the realm of speculation. Some scientists argue that the many worlds interpretation is simply an elegant mathematical construct, a way to reconcile the counterintuitive nature of quantum mechanics without invoking wave function collapse. But elegance is not the same as truth. A beautiful equation is not necessarily a reflection of reality. There is also the problem of Occam's razor, the principle that the simplest explanation is usually the best. The many worlds. Interpretation is anything but simple. It proposes the existence of an infinite number of universes constantly branching off from each other. It is a mind-bogglingly complex scenario, far more complex than other interpretations of quantum mechanics. Alternative interpretations, such as the Copenhagen interpretation, offer a more conservative approach. They acknowledge the weirdness of quantum mechanics, but avoid the need for parallel universes. Instead, they focus on the role of observation in collapsing the wave function, arguing that it is the act of measurement that brings a quantum system into a definite state. While the Copenhagen interpretation has its own set of challenges and criticisms, it remains a viable alternative to the many worlds interpretation for many physicists. It is simpler, more intuitive, and does not require the existence of countless unseen universes. Furthermore, the very idea of quantum immortality relies on a particular interpretation of quantum mechanics, one that is still hotly debated. There are other, equally valid interpretations that do not support the notion of branching timelines or subjective survival. The Gherardi-Rimini-Weber theory, for example, proposes a spontaneous collapse of the wave function, regardless of whether an observation is made. This theory suggests that quantum superpositions are inherently unstable and that they collapse into a single state due to some unknown mechanism. If this is true, then the basis for quantum immortality crumbles, as there are no branching universes to navigate. Even if the many worlds interpretation is correct, there are still significant challenges to the concept of quantum immortality. One of the biggest is the issue of probability. While the theory suggests that you will always survive from your own perspective, it does not guarantee a pleasant or even a desirable existence. Imagine surviving a catastrophic event only to find yourself in a world ravaged by disease, famine, and endless conflict. You might be the only conscious being left alive, trapped in a desolate wasteland, forever haunted by the ghosts of the past. Is that truly immortality? Is that truly survival? Moreover, the odds of surviving some catastrophic event are often infinitesimally small. Relying on quantum immortality is like playing a cosmic lottery with near impossible odds. While it might be comforting to believe that you are destined to survive, it is also incredibly reckless. Some scientists also question the very definition of consciousness and its role in quantum mechanics. Does consciousness play a fundamental role in shaping reality, as some interpretations suggest? Or is it merely a byproduct of complex brain activity, an emergent property that has no influence on the quantum world? The answer to this question is far from clear, and it has profound implications for the concept of quantum immortality. If consciousness is not fundamental, then it is difficult to see how it could navigate branching timelines or influence the outcome of quantum events. It is essential to remember that quantum immortality is a thought experiment, not a proven scientific fact. It is a fascinating exploration of the implications of quantum mechanics, but it should not be mistaken for reality. The thought experiment, fundamentally flawed, remains untestable. It can be argued that it is more metaphysics than physics. As with any scientific theory, skepticism is a healthy and necessary component of the scientific process. It is through rigorous questioning, critical analysis, and a willingness to challenge assumptions that we can ultimately arrive at a deeper understanding of the universe. Could near-death experiences serve as glimpses into the process of consciousness-shifting timelines? But even as the scientific community grapples with the testability and plausibility of quantum immortality, a labyrinth of philosophical questions emerges, a maze of ethical and existential dilemmas that must be navigated. Because beyond the equations and the interpretations, the thought experiment forces us to confront fundamental aspects of our existence. What, after all, truly defines who we are? If countless versions of you exist across infinite timelines, making different choices, experiencing different lives, what constitutes your unique personal identity? Is it your physical body, the specific arrangement of atoms that make up your form? But that body is constantly changing, shedding cells, replacing molecules. It is not the same body you had 10 years ago, or even 10 seconds ago. Is it your memories, then? The sum total of your experiences, your triumphs, your failures, your loves, and your losses? But memories are notoriously unreliable, subject to distortion, embellishment, and outright fabrication. And in a multiverse teeming with infinite possibilities, there are countless versions of you with different memories, different histories, different perspectives. Perhaps it is your consciousness itself, that elusive sense of self-awareness that animates your being. But what is consciousness, really? Where does it come from? And how does it persist across branching universes? Is it a single, unified entity, or a collection of disparate experiences constantly merging and diverging? Some philosophers argue that personal identity is an illusion, a convenient fiction that we construct to make sense of our lives. They propose that we are not single, enduring selves, but rather fluid, ever-changing collections of experiences, constantly being shaped by our interactions with the world. Think of it like a river. It is always flowing, always changing, yet we still refer to it as the same river. The water is different, the banks are different, even the course of the river may change over time. But there is still a continuity, a sense of identity that persists despite all the changes. Perhaps our sense of self is similar, a continuous flow of experience that binds us together, even as we branch off into countless different realities. But what happens when that flow is disrupted? What happens when we encounter a version of ourselves who has made drastically different choices, who has lived a completely different life? This raises another profound question. Does survival in a vastly degraded state count as a victory? Imagine surviving a nuclear holocaust, only to find yourself living in a world devoid of hope, a world where life is a constant struggle for survival. You might be physically alive, but are you truly living? Is that existence truly meaningful? Perhaps you are trapped in a vegetative state, your body broken, your mind unable to function. You are technically alive, but are you still you? Has your consciousness been diminished to the point where it no longer resembles the person you once were? These are not easy questions to answer. They force us to confront our deepest fears, our most profound anxieties about the nature of existence. They challenge us to reevaluate what we truly value in life and what we are willing to sacrifice in order to survive. Some might argue that any form of survival is better than non-existence, that even a degraded existence is preferable to the oblivion of death. But others might disagree, arguing that there is a point where life becomes unbearable, where the suffering outweighs the benefits, where death is a welcome release. The question of whether survival in a vastly degraded state counts is deeply personal and subjective. It depends on our individual values, our individual beliefs, and our individual tolerance for suffering. There is no right or wrong answer, only a complex web of ethical and existential considerations. What truly constitutes a meaningful existence, then? Is it the pursuit of happiness, the accumulation of knowledge, the creation of art, the love of family and friends? Or is it something more fundamental, something inherent in the very act of being conscious, of experiencing the world around us? Perhaps the answer lies in recognizing that life is not just about survival, but about thriving. It is about finding meaning and purpose in our existence, about making a positive contribution to the world, about leaving a lasting legacy that will outlive us. Surviving the hardest times in our multiverse does not make us better. Quantum immortality might offer a glimpse into the possibility of eternal survival, but it does not guarantee a life worth living. It is up to us, individually and collectively, to create a world where survival is not just a possibility, but a privilege, a chance to experience the full spectrum of human potential. In the meantime, what if we can't find that meaning and just grow old in this infinite timeline? Infinite. Can quantum immortality stop time and aging, or can it at least slow it down? Even as we navigate potential nuclear holocausts and global pandemics with the possible cheat code of quantum immortality, a more personal, inevitable foe looms on the horizon: aging. The inexorable march of time, the gradual decline of our physical form, the eventual certainty of natural death. If quantum immortality can help us dodge bullets and viruses, could it also offer a loophole against senescence? Is the fountain of youth hidden within the quantum realm? For millennia, humanity has sought to conquer aging, to unlock the secrets of eternal youth. From ancient alchemists concocting elixirs of immortality to modern scientists probing the mysteries of genetics, the quest for longevity has been a constant driving force. Cleopatra, the legendary queen of Egypt, was said to bathe in donkey milk, believing it would preserve her youthful beauty. Ponce de Leon, the Spanish conquistador, famously searched for the fountain of youth in Florida, a mythical spring said to restore the vitality of anyone who drank from its waters. Today, that quest continues, albeit with a more scientific approach. Researchers are exploring everything from gene therapy and stem cell regeneration to caloric restriction and the use of drugs like metformin and rapamycin, all in the hopes of slowing down or even reversing the aging process. But what if the answer lies not in biology, but in physics? What if quantum immortality offers a way to cheat, not just sudden death, but the slow, inevitable decline of our physical form? The traditional understanding of quantum immortality focuses on surviving external catastrophes, events with a clear probabilistic outcome. You either live or you die. But aging is different. It's not a single event, but a gradual process, a complex cascade of biological changes that accumulate over time. Can quantum immortality apply to such a continuous, non-probabilistic phenomenon? Let us consider a thought experiment. Imagine you are 80 years old, your body showing the wear and tear of decades of life. Your joints ache, your vision is failing, your memory is fading. In most timelines, this decline continues, leading eventually to death from old age. But what if, in one particular timeline, something different happens? What if, at the very moment when your body is about to succumb to the ravages of time, a quantum event occurs that somehow reverses the aging process? Perhaps a burst of cosmic radiation triggers a cascade of cellular regeneration, restoring your body to its youthful prime. Or maybe a team of scientists discovers a revolutionary gene therapy that erases the effects of aging, turning back the clock on your cells. These scenarios might seem far-fetched, but remember, quantum immortality is all about embracing the improbable, the statistically unlikely. If such a quantum event were to occur, would your consciousness shift to that timeline, experiencing the sudden reversal of aging? Would you find yourself waking up one morning, decades younger, your body rejuvenated, your mind sharp and clear? It is a tantalizing possibility, one that challenges our fundamental understanding of time and aging. But here is where things get complicated. Aging is not just a matter of physical decline. It's also a matter of identity. Our memories, our experiences, our relationships, all contribute to who we are. If we were to suddenly become decades younger, would we still be the same person? Would we still retain our memories, our personalities, our sense of self? Perhaps the quantum reversal of aging would also involve a rewriting of our memories, a shift in our perception of time so that we seamlessly integrate our younger selves with our older experiences. Or maybe we would find ourselves struggling to reconcile our youthful bodies with our older minds, caught between two different identities. It is also important to consider the ethical implications of such a scenario. If quantum immortality can indeed offer a loophole against senescence, who would have access to it? Would it be available to everyone or only to a select few? Would it exacerbate existing inequalities, creating a world where the rich and powerful live forever, while the rest of humanity continues to age and die? And what about the impact on society? A world without aging would be a drastically different place, with profound consequences for population growth, resource allocation, and the very fabric of human relationships. Would we still value youth, or would we come to appreciate the wisdom and experience of age? The question of whether quantum immortality can stop time is a complex and multifaceted one with no easy answers. While it might be tempting to imagine a world where we can cheat death and live forever in youthful bodies, it is crucial to consider the potential consequences both for ourselves and for society as a whole. The quest for eternal youth is as old as humanity itself, and perhaps ultimately it is the journey that truly matters, not the destination. In the meantime, let's search the universe and look for any proof and echoes in reality if many worlds exists. Even as we navigate potential nuclear holocausts and global pandemics with the possible cheat code of quantum immortality, a question lingers like a persistent echo in the halls of science. Is there any tangible evidence, however faint, that these branching realities, these many worlds, actually exist? Are we forever confined to this single timeline, or can we catch a glimpse, a whisper, a shadow of another world playing out alongside our own? This isn't just about philosophical musings or thought experiments anymore. This is about the cold, hard pursuit of scientific verification. It is about venturing into the unknown armed with instruments, equations, and an unyielding curiosity. But where do we even begin to look for evidence of something so fundamentally elusive? Is the quest even possible, or are parallel universes destined to remain forever beyond our reach, locked away in the realm of theoretical abstraction? The answer, perhaps surprisingly, may lie in the very fabric of the cosmos itself. Scientists are scouring the sky, analyzing the cosmic microwave background radiation, the afterglow of the Big Bang, for subtle anomalies, for telltale patterns that might betray the presence of other universes. Imagine the early universe, an infinitely dense and chaotic soup of energy and matter. If other universes existed alongside our own, could they have left their imprint on this primordial soup? Could they have collided, interacted, or entangled with our universe in some way, leaving behind subtle distortions in the cosmic microwave background? It would be like searching for ripples on a pond, hoping to trace them back to a pebble tossed in from another dimension. It is a long shot, to be sure, but the potential payoff is enormous. If we could detect such anomalies, it would be the first concrete evidence of the multiverse, a game changer that would revolutionize our understanding of the universe and our place within it. But the search for parallel universes isn't confined to the distant reaches of space. Scientists are also exploring the possibilities of quantum computing, a revolutionary technology that harnesses the power of quantum mechanics to perform calculations far beyond the capabilities of classical computers. Quantum computers rely on qubits, quantum bits that can exist in a state of superposition, representing both 0 and 1 simultaneously. This allows them to explore multiple possibilities at once, performing calculations in parallel. Some physicists argue that the power of quantum computers hints at the reality of parallel computations occurring in other worlds. Could it be that quantum computers are tapping into the resources of other universes, harnessing their computational power to solve complex problems? Is quantum computing, in a way, a backdoor into the multiverse? It is a fascinating idea, one that suggests that the development of quantum computing could not only revolutionize technology, but also provide evidence for the many worlds interpretation. Perhaps by studying the behavior of quantum computers, we can glean insights into the nature of parallel universes, and even learn to communicate with them. Beyond cosmology and quantum computing, theoretical physicists are constantly pushing the boundaries of our understanding, developing new models and theories that could potentially provide clues about the multiverse. Some are exploring the possibility of wormholes, hypothetical tunnels through space-time that could connect distant regions of our universe, or even different universes altogether. Imagine a wormhole as a cosmic shortcut, a bridge that allows us to travel vast distances in a fraction of the time it would take to travel through normal space. If wormholes exist, could they be used to travel to other universes, to explore the infinite possibilities of the multiverse? The concept remains highly speculative, but scientists are actively searching for evidence of wormholes, looking for subtle gravitational anomalies that might betray their presence. If we could find and stabilize a wormhole, it would be a game changer, opening up a gateway to the multiverse and revolutionizing our understanding of space and time. These parallel universes remain purely theoretical for now, but scientists are continuously exploring the advancements and clues that may lead to understanding other dimensions. The quest goes on, and maybe, just maybe, the answer lies just beyond our current perception, ready to be discovered, altering our reality as we know it. Even as we search for echoes of other universes in the cosmic microwave background, a far more intimate and personal mystery beckons. What happens when we brush against the veil of death? When the body shuts down, the senses fade, and the mind teeters on the brink of oblivion. Is it simply the end, a final full stop to our conscious existence? Or is it something more, something stranger? Could near-death experiences, or NDEs, provide a tantalizing clue, a whisper from beyond the threshold? For centuries, stories have circulated of individuals who have clinically died only to return with extraordinary tales of otherworldly encounters. They speak of floating above their bodies, observing the frantic efforts of doctors and nurses trying to revive them. They describe traveling through dark tunnels towards a radiant light, a beacon of love and peace. They encounter deceased loved ones, bathed in an ethereal glow, offering comfort and guidance. And they often experience a panoramic life review, a rapid-fire replay of their entire existence, every joy, every sorrow, every triumph, every failure flashing before their eyes. These accounts, remarkably consistent across cultures and belief systems, have fueled speculation and debate for decades. Are they simply hallucinations, elaborate fabrications of a dying brain struggling to make sense of its own demise? Or could they represent something more profound, a glimpse into another realm, a fleeting connection to a reality beyond our own? One compelling explanation, rooted in the principles of quantum immortality, suggests that near-death experiences could be glimpses into the process of consciousness-shifting timelines. Imagine, if you will, that death is not a single definitive event, but rather a branching point, a fork in the road where our consciousness can choose to follow different paths. In most timelines, death leads to oblivion, the cessation of conscious experience. But in at least one timeline, our consciousness persists, finding a way to continue existing, perhaps by shifting to another universe where we survive. Could near-death experiences represent the moment of that transition, the brief glimpse into the other timelines before our consciousness fully commits to its new reality? Think of it like this. You are driving down a highway, approaching a fork in the road. In one direction, a massive traffic jam stretches as far as the eye can see. In the other direction, the road is clear, open, and inviting. As you approach the fork, you briefly glimpse both possibilities. the endless frustration of the traffic jam and the exhilarating freedom of the open road. Near-death experiences might be similar, a brief glimpse into the various timelines that branch off from the moment of death, a fleeting awareness of the possibilities that lie beyond. The tunnel of light, the encounters with loved ones, the life review could all be aspects of these alternative realities, fragments of information leaking through from other universes. Now, I know what you might be thinking. This sounds like pure speculation, a fanciful attempt to connect quantum physics with the paranormal. But there is a growing body of scientific research that is beginning to shed light on the mysteries of near-death experiences. Neuroscientists are studying the brain activity of patients who have experienced near-death experiences, looking for patterns that might explain these unusual phenomena. Some studies have found evidence of increased brain activity in certain regions of the brain during near-death experiences, suggesting that they are not simply the result of brain shutdown. Other researchers are exploring the role of neurotransmitters, the chemical messengers that transmit signals between nerve cells. They are investigating whether certain neurotransmitters, such as serotonin and dopamine, might be involved in the generation of near-death experiences. It's like trying to decipher a complex code, searching for the key that will unlock the secrets of consciousness and the mysteries of death. One fascinating area of research involves the use of hallucinogenic drugs, such as psilocybin and DMT, which have been shown to induce experiences that are strikingly similar to near-death experiences. These drugs can alter perception, distort time, and evoke intense feelings of transcendence, often accompanied by encounters with otherworldly entities. By studying the effects of these drugs on the brain, scientists hope to gain a better understanding of the neural mechanisms that underlie near-death experiences. It's like exploring a parallel universe within our own minds, using the tools of science to map the uncharted territories of consciousness. Now, I want to emphasize that this research is still in its early stages, and there is no definitive scientific explanation for near-death experiences. But the evidence is growing that these experiences are not simply random hallucinations, but rather complex and meaningful events that reflect something profound about the nature of consciousness and reality. Could they be glimpses into the quantum realm, fleeting connections to the multiverse? It's a question that continues to challenge scientists and philosophers alike. Regardless of their ultimate explanation, near-death experiences offer a powerful reminder of the mysteries that lie beyond the veil, the uncharted territories of consciousness that we are only just beginning to explore. But where does this consciousness come from? The ultimate question remains, and until we answer this question, we will not find quantum immortality. And so, as we stand at the precipice of understanding near-death experiences, peering into the potential for consciousness to shift timelines like a phantom navigating a maze, a question of colossal magnitude looms. It is a question that has echoed through the ages, whispered by philosophers, pondered by poets, and wrestled with by scientists. What, in its essence, is consciousness? Where does it reside? How does it relate to the physical world, to this intricate dance of quantum possibilities we've been exploring? Is it, as some neuroscientists believe, simply the emergent property of the brain, a symphony of electrical and chemical signals firing across billions of neurons, a complex biological algorithm churning out thoughts, emotions, and sensations? Consider the human brain, a 3-pound organ containing roughly 100 billion neurons, each connected to thousands of others. It's a network of unfathomable complexity, a universe within a universe. Could this intricate web of connections, this electrochemical storm, be all that there is to consciousness? Could subjective experience, the feeling of being you, be nothing more than a sophisticated illusion conjured up by our brains? Or is consciousness something more, something fundamental, something that transcends the limitations of the physical brain? Is it possible, as proponents of panpsychism suggest, that consciousness is a basic property of the universe, present in all matter to varying degrees? That every atom, every molecule, every particle possesses some glimmer of awareness, however faint? It's a startling idea, one that challenges our conventional understanding of the universe and our place within it. But consider this. If consciousness is purely a product of complex brain activity, how did it arise in the first place? How did inanimate matter suddenly gain the capacity for subjective experience? Perhaps, as some philosophers argue, consciousness is not something that emerges from matter, but something that is always present, a fundamental aspect of reality like space, time, or gravity. In this view, the brain is not the source of consciousness, but rather a filter or a receiver tuning into a pre-existing field of awareness that permeates the universe. It is a wild thought, challenging the very foundation of scientific thought and perhaps leaning into something previously considered pure science fiction. Think of it like a radio. The radio does not create the music. It simply receives and amplifies radio waves that are already present in the environment. Similarly, the brain might not create consciousness, but rather receive and process a pre-existing field of awareness. But if consciousness is indeed fundamental, how does it interact with the physical world? How does it influence our thoughts, our actions, our perceptions? This is where the mystery deepens, leading us back to the strange and perplexing realm of quantum mechanics. Remember the double-slit experiment where the act of observation seems to influence the behavior of electrons? Could it be that consciousness plays a role in collapsing the wave function, in bringing quantum possibilities into concrete reality? Perhaps the universe is not just a collection of particles and forces, but a vast, interconnected network of conscious observers, each shaping reality through their very awareness. Is it awareness that has influence, or is it only observation that alters our perception of things? It's a dizzying idea, one that blurs the line between science and philosophy, between the objective and the subjective. But it forces us to confront the most fundamental questions about our existence. What is the relationship between mind and matter? What is the nature of reality? And what role does consciousness play in shaping the universe we experience? The quantum immortality hypothesis suggests the answer to all of these questions could be more intrinsically linked than we could have previously imagined. As we delve deeper into the mysteries of consciousness, we encounter a multitude of competing theories, each with its own strengths and weaknesses. From neuroscience to panpsychism, from quantum mechanics to philosophy, the quest to understand consciousness is a multidisciplinary endeavor, a grand collaboration that spans centuries of human thought. Is it something we can test with math, science, and calculations, or is it something that we need to connect with spiritually? Understanding the essence of consciousness is not merely an academic exercise. It is crucial to evaluating the plausibility of quantum immortality. If consciousness is simply a product of the brain, then it is difficult to see how it could persist after death, how it could navigate branching timelines, how it could defy the laws of physics. But if consciousness is fundamental, if it transcends the limitations of the physical body, then the possibility of quantum immortality becomes, perhaps, a little less far-fetched. It is as if the universe is fine-tuned for life after all. Even as we begin to dissect the fundamental components of our consciousness and its function in this vast multiverse, an even stranger question arises. If you truly believed, deep in your bones, that you were quantumly immortal, how would that affect your actions? Would you suddenly become a daredevil, leaping from skyscrapers and wrestling alligators, secure in the knowledge that, from your perspective, you would always survive? Would the sting of consequence simply vanish, replaced by a reckless abandon, a devil-may-care attitude towards life and limb? It is a chilling thought experiment, one that forces us to confront the psychological and behavioral implications of perceived immortality. Imagine a world where people genuinely believed they could not truly die, a world where the fear of death, that fundamental human motivator, had been effectively neutralized. What kind of society would that be? Would it be a utopia of fearless exploration and boundless creativity, or a dystopia of utter chaos and reckless self-destruction? Consider the story of Icarus, the mythical Greek figure who flew too close to the sun, his wax wings melting and sending him plummeting to his death. Icarus, in a way, represents the dangers of hubris, the overweening pride that can lead to downfall. If Icarus had believed himself to be quantumly immortal, would he have flown even higher, even closer to the sun, confident in his ability to survive any catastrophe? Would that perceived immortality have ultimately sealed his fate, leading to a more spectacular and devastating demise? Or think of the tightrope walker Philippe Petit, who famously walked across a wire strung between the twin towers of the World Trade Center in 1974. It was an act of breathtaking audacity, a death-defying feat that captivated the world. Was Petit fearless because he possessed an unwavering belief in his own skill and preparation, or because, deep down, he harbored a secret conviction that he was somehow destined to survive? Would the knowledge of quantum immortality have emboldened him even further, allowing him to attempt even more daring and dangerous stunts? Perhaps the most compelling exploration of this theme can be found in the realm of extreme sports. Base jumping, free solo climbing, wingsuit flying, these activities push the boundaries of human endurance and skill, flirting with death in a way that most of us can barely comprehend. What motivates these individuals to risk their lives in such spectacular fashion? Is it the adrenaline rush, the sense of accomplishment, the desire to conquer fear, or is it something more, something akin to a subconscious belief in their own invincibility? Imagine a base jumper standing on the edge of a cliff, preparing to leap into the void. They have calculated the trajectory, checked their equipment, and visualized the jump 1,000 times in their mind. But there is always an element of risk, a chance that something could go wrong. A gust of wind, a equipment malfunction, a momentary lapse in concentration. Any of these could spell disaster. If that base jumper believed they were quantumly immortal, would they approach the jump differently? Would they be more reckless, more willing to take chances? Would they discard safety protocols, relying instead on a belief that they would somehow, inevitably, survive? It is a dangerous proposition, a recipe for disaster. Because even if quantum immortality is real, it doesn't guarantee a pleasant or even a desirable outcome. It only guarantees that your consciousness will persist, finding a way to continue existing, however improbable that may seem. You might survive the base jump, only to find yourself paralyzed, trapped in a hospital bed for the rest of your days. You might survive a plane crash, only to be stranded on a desert island, struggling to survive in a harsh and unforgiving environment. The universe does not owe you a comfortable existence. It only promises to keep you alive in some form or another. The psychological impact of believing in quantum immortality could be profound, potentially leading to a dangerous disconnect from reality. It could foster a sense of entitlement, a belief that you are somehow special, that the rules don't apply to you. It could erode your empathy, your compassion for others, as you become increasingly focused on your own survival, regardless of the consequences. Perhaps the key lies in understanding the difference between confidence and arrogance, between a healthy respect for risk and a reckless disregard for danger. It is possible to believe in your own resilience, to cultivate a sense of inner strength and determination without falling prey to the illusion of invincibility. It is about embracing life to the fullest, while also recognizing the inherent fragility of existence. It is about living with purpose, with passion, with a deep appreciation for the beauty and wonder of the world around us. It is about making a positive contribution, about leaving a lasting legacy, about cherishing the relationships that give our lives meaning. After all, even if quantum immortality is real, it is not a substitute for a life well lived. As the saying goes, it is not the years in your life that count, it is the life in your years. So even if you held this perceived immortality, would it truly hold any effect on how you live? Would you live without care, without fear, with reckless abandon? Or would you take new precautions for your life and the lives of others? If survival is guaranteed, does it then remove the sting of consequence? If anything, quantum immortality serves as a stark reminder of the preciousness of life, of the importance of making every moment count. Does the universe even favor observers, or are we just a series of improbably lucky people? Even if you believed in your soul that you were quantumly immortal, the question remains, what are the potential pitfalls to our eternal subjective awareness? You have dodged the asteroid, weathered the nuclear storm, and outsmarted the pandemic. But what awaits you in these surviving timelines? Is it a world of sunshine and rainbows, or something far more bleak, more desolate, more profoundly unsettling? The universe is a vast, indifferent expanse, and survival doesn't always equate to a pleasant existence. Picture yourself, the sole survivor of a catastrophic event. The world around you is shattered, a desolate wasteland scarred by fire and radiation. Cities lie in ruins, the air is thick with toxic dust, and the very earth seems to groan in agony. You scavenge for food, battling starvation and disease, haunted by the memories of a world that is no more. Is this the immortality you envisioned, this endless struggle for survival in a world devoid of hope? Or consider another scenario. You survive a plane crash, but the cost is steep. Your body is broken, your mind shattered. You are trapped in a hospital bed, unable to move, unable to speak, unable to communicate with the world around you. Your consciousness persists, but it is trapped in a prison of flesh, a silent observer of your own suffering. Is this mere continuation truly desirable, this endless torment with no escape? Perhaps quantum immortality is not a gift, but a curse, a cosmic prank played on unsuspecting souls. Perhaps it is a path that leads not to eternal bliss, but to eternal suffering, an endless cycle of survival in increasingly horrific and degraded states. You manage to scrape by. You manage to move from one side of the catastrophe to another. What comes after? Imagine a world where quantum immortality is a reality, a world where everyone is destined to survive, no matter the odds. But what happens to the quality of life in such a world? What happens to the value of human connection, to the importance of empathy and compassion? If death loses its sting, does life also lose its meaning? Could such a world devolve into a brutal Hobbesian state of nature, where everyone is for themselves, where survival is the only goal and morality is a distant memory? Could it lead to a dangerous disregard for the well-being of others, as individuals become increasingly focused on their own survival, regardless of the consequences? Perhaps the most chilling aspect of quantum immortality is the potential for isolation. Imagine surviving a global catastrophe, only to discover that you are the last human being left alive. The weight of existence falls squarely on your shoulders, the crushing loneliness of being the sole witness to the end of the world. You wander through the ruins of civilization, searching for other survivors, but finding only silence and desolation. Is that what you thought was your destination as your consciousness moved to a new universe? The renowned author Cormac McCarthy explored this theme in his post-apocalyptic novel, The Road, a haunting tale of a father and son struggling to survive in a world ravaged by an unnamed cataclysm. The novel is a stark reminder of the fragility of human existence and the importance of love, hope, and connection in the face of unimaginable adversity. The characters in The Road are not quantumly immortal. They are not guaranteed to survive, but they possess a fierce determination to keep going, to protect each other, to find meaning in a world that seems to have lost all meaning. Their survival is not a certainty, but a choice, a conscious act of defiance against the forces of despair. Perhaps that is the key. Perhaps the true test of quantum immortality is not simply whether we can survive, but how we choose to live in the face of survival. It is about finding meaning and purpose in a world that may be broken, degraded, or profoundly unsettling. It is about maintaining our humanity, our empathy, our compassion, even when all seems lost. After all, the universe is not a vending machine, dispensing happiness and fulfillment on demand. It is a vast, indifferent expanse, full of beauty and wonder, but also full of hardship and suffering. To truly live, to truly thrive, we must embrace both the light and the darkness, the joy and the sorrow, the triumphs and the tragedies. The influential philosopher Friedrich Nietzsche wrote of the concept of amor fati, the love of fate. It is about accepting everything that life throws our way, both the good and the bad, as necessary and integral parts of our journey. It is about finding meaning in our suffering, about using our challenges to grow stronger, wiser, and more compassionate. Quantum immortality might offer the possibility of endless survival, but it is up to us to decide what we will do with that survival. Will we succumb to despair, to selfishness, to apathy, or will we choose to live with purpose, with passion, with a deep appreciation for the preciousness of life? The choice is ours, and it is a choice that will shape not only our own destiny, but the destiny of the world around us. We must then ask the question, what realities exist beyond the many worlds? What if our understanding of the quantum world, with its branching realities and potential for subjective immortality, is just one piece of a much larger, more intricate puzzle? It is tantalizing to imagine that our consciousness can navigate these infinite timelines, but is the many worlds interpretation the only lens through which we can view this cosmic dance? The truth is, the many worlds interpretation, as revolutionary as it is, isn't the only game in town when it comes to quantum mechanics. For decades, physicists have grappled with the mysteries of the quantum world and have proposed a range of alternative theories, each with its own unique perspective on reality. Understanding these alternatives is not just an academic exercise, but a crucial step in evaluating the plausibility of quantum immortality. Because if the many worlds interpretation is flawed, then the foundation upon which quantum immortality rests may also crumble. Perhaps the most well-known alternative is the Copenhagen interpretation, the old guard, if you will. Developed by Niels Bohr and Werner Heisenberg in the 1920s, it remains the most widely accepted interpretation of quantum mechanics among physicists today. In this view, quantum systems exist in a state of superposition, a mixture of all possible states until they are measured. But here's the crucial difference. Unlike the many worlds interpretation, the Copenhagen interpretation posits that the act of measurement causes the wave function to collapse, forcing the system to choose a single definite state. There is no branching of timelines, no parallel universes, just a single objective reality that is revealed through observation. So, what does this mean for quantum immortality? Well, if the Copenhagen interpretation is correct, then the idea of consciousness shifting between timelines becomes nonsensical. There are no other timelines to shift to. Death is simply the end, the cessation of conscious experience. The wave function collapses, and the story is over. There is no cosmic safety net, no quantum loophole, no guaranteed survival. But the Copenhagen interpretation is not without its own challenges. It raises difficult questions about the nature of measurement and the role of the observer. What exactly constitutes a measurement? Does it require a conscious observer, or can any form of interaction trigger wave function collapse? And if consciousness is required, does that mean that reality is somehow dependent on our minds? These are questions that have plagued physicists for decades, and there is no easy answer. Some have proposed that consciousness is not necessary for wave function collapse, that any form of interaction with the environment is sufficient. Others have argued that consciousness does indeed play a fundamental role, suggesting that the universe is somehow participatory, shaped by our very awareness. Another intriguing alternative to the many worlds interpretation is pilot wave theory, also known as Bohmian mechanics. Developed by David Bohm in the 1950s, this theory offers a deterministic interpretation of quantum mechanics, one that eliminates the need for wave function collapse and parallel universes. In pilot wave theory, particles are not simply point-like objects, but rather complex entities that are guided by a pilot wave, a hidden variable that determines their trajectory. The pilot wave is not directly observable, but it influences the behavior of particles, causing them to exhibit the strange and counterintuitive phenomena observed in quantum experiments. Think of it like a surfer riding a wave. The surfer is the particle, and the wave is the pilot wave. The surfer is not free to move independently, but is rather guided by the shape and movement of the wave. Similarly, particles in pilot wave theory are not free to move randomly, but are guided by the pilot wave, which determines their path through space and time. So what does this mean for quantum immortality? Well, if pilot wave theory is correct, then the idea of branching timelines and consciousness shifting between them becomes unnecessary. There is only one reality, one pilot wave, and one set of particles following a predetermined path. Death is simply the end of that path, the cessation of particle movement. There is no multiverse to navigate, no quantum escape route. But pilot wave theory also has its critics. Some argue that it is too complex, that it introduces unnecessary hidden variables that cannot be observed or tested. Others argue that it fails to adequately explain certain quantum phenomena, such as entanglement and non-locality. Is it simply too difficult for scientists and theorists to accept? These are just a few of the many alternative interpretations of quantum mechanics that have been proposed over the years. Each offers a unique perspective on reality, and each has its own strengths and weaknesses. While the many worlds interpretation has gained popularity in recent years, it is by no means the only game in town. Perhaps as we delve deeper into these complex theoretical quandaries, we can finally harness the power of quantum computers. They rely on harnessing quantum superposition and entanglement, and can begin to lend us some credence to the many worlds framework. Even as we analyze what realities exist beyond the many worlds and all alternative dimensions, there is an even deeper idea to explore. Can we understand it and make sense of it with movies, books, or maybe in video games? What happens when the abstract concepts we have been discussing enter the realm of storytelling? Can the complex ideas of quantum immortality and the multiverse actually be grasped and understood through the power of science fiction? For decades, science fiction authors, filmmakers, and game designers have grappled with the very themes we have been dissecting: parallel universes, time travel, and the quest for immortality itself. But how have they portrayed the concept of quantum immortality, and what can we learn from these fictional explorations? Think about it. Science fiction is more than just spaceships and aliens. It's a powerful tool for exploring profound philosophical questions, for pushing the boundaries of human imagination, and for holding a mirror up to our own society. It is about understanding how writers and other creators use stories as a window into these topics, and maybe we can all understand this strange topic together. One of the most compelling examples can be found in the novel The Man in the High Castle by Philip K. Dick. In this alternate history, the Axis powers won World War II, and the United States has been divided between Japan and Nazi Germany. The story follows characters navigating this oppressive reality, while also encountering whispers and rumors of another timeline, a timeline where the Allies were victorious. This isn't quite quantum immortality in the strictest sense, but it explores the idea that reality is not fixed, that there are alternate possibilities, and that our choices can have profound consequences. The characters in The Man in the High Castle are haunted by the knowledge that their world could have been different, and is there a way to still find them even when you move through the timeline? Another fascinating example is the film Sliding Doors, which presents a more personal and intimate exploration of alternate realities. The film follows a woman whose life diverges into two different paths depending on whether or not she catches a train. One path leads to a fulfilling romance and career success, while the other leads to heartbreak and disappointment. This isn't about dodging death and finding a timeline where she survives. This is about different choices, and how there is always a different version of yourself doing something else. Sliding Doors doesn't explicitly deal with quantum mechanics, but it captures the feeling of living in a multiverse, the sense that our lives are shaped by chance encounters and split-second decisions that can alter the course of our destiny. But it always gives you a chance to consider what if, and that alone can change your perspective and move you forward. The concept of quantum immortality is explored more directly in the science fiction novel Permutation City by Greg Egan. The book centers around a scientist who creates a virtual reality simulation of himself, a perfect copy of his consciousness that can exist indefinitely within the digital world. As the scientist delves deeper into this simulation, he begins to question the nature of reality itself, wondering if his own existence is nothing more than a similar simulation created by some higher power. How can we tell what is real and what is not? It makes you start to question everything around you, and even the book itself. Egan's novel tackles the philosophical implications of quantum immortality head-on, exploring the nature of identity, consciousness, and the meaning of survival in a multiverse where anything is possible. It's a mind-bending exploration of the human condition, forcing us to confront the deepest questions about our place in the cosmos. Maybe this book is something you need to put on your reading list. In the realm of video games, the BioShock franchise offers a compelling take on alternate realities and the consequences of unchecked ambition. The original BioShock takes place in the underwater city of Rapture, a utopian society founded on the principles of objectivism that has descended into chaos and ruin. As the player explores the ruins of Rapture, they encounter echoes of the past, glimpses into the lives of the city's former inhabitants, and the devastating consequences of their choices. The game doesn't explicitly deal with quantum immortality, but it explores the idea that our actions can have ripple effects that extend far beyond our own lives, shaping the destinies of entire societies, and if you are not careful, it may be a grim one. More recently, the video game Quantum Break directly tackles the concept of time manipulation and its potential consequences. The game's protagonist gains the ability to control time after a failed experiment, allowing him to rewind, fast forward, and even stop time altogether. As he grapples with his newfound powers, he uncovers a conspiracy that threatens to unravel the fabric of reality. Quantum Break explores the ethical dilemmas of manipulating time, the potential for paradoxes and unforeseen consequences, and the importance of cherishing the present moment. This isn't about immortality and surviving whatever comes. It is about saving the world by changing how it works. So, what can we learn from these fictional explorations of quantum immortality? What insights can they offer into the nature of consciousness, reality, and the human condition? Perhaps the most important lesson is that these concepts should not be seen as a guarantee of eternal bliss, but rather as a reminder of the preciousness of life. The power of fiction is an important one and should not be overlooked in trying to understand the world around us, and even worlds we haven't discovered yet. Science fiction offers a playground for exploring these ideas, allowing us to grapple with complex concepts in a safe and engaging way. It is a tool that is there to guide us with tough-to-swallow ideas, and maybe we all need a little guidance in life. These alternate realities may never be anything but fiction, but they are always there to help us prepare. But let's not spend all our time in fantasy. It's time to bring back real life. Science fiction can provide intriguing thought fodder, but let's ground ourselves firmly in the realm of what we know, and perhaps more importantly, what we don't know. Because amidst the captivating possibilities of quantum immortality, it's easy to lose sight of one fundamental truth. This entire concept exists within the boundaries of a thought experiment, not a proven scientific fact. It is a playground for the mind, a theoretical exploration of the implications of quantum mechanics, but it must be approached with a healthy dose of skepticism and a clear understanding of its limitations. Think of it as navigating an uncharted ocean. We have a map, a compass, and a burning desire to explore, but we must also be aware of the dangers that lie beneath the surface, the treacherous currents and hidden reefs that could wreck our ship. What then? are the inherent limitations of the quantum immortality thought experiment. Where does the realm of theoretical possibility end and the realm of empirical reality begin? These are crucial questions that must be addressed if we are to avoid falling into the trap of pseudoscience or wishful thinking. One of the most significant limitations is the sheer untestability of the theory. How can we possibly verify the existence of branching timelines? How can we prove that consciousness shifts between universes in moments of crisis? These are questions that may be forever beyond the reach of scientific inquiry. It is like trying to capture smoke with a net. The more we try to grasp it, the more it slips through our fingers. Furthermore, quantum immortality relies heavily on the many worlds interpretation of quantum mechanics, a theory that is itself far from universally accepted. While it has gained popularity in recent years, it remains a minority view among physicists, with many preferring alternative interpretations that do not require the existence of parallel universes. So, even if we accept the theoretical framework of quantum mechanics, there is no guarantee that quantum immortality is a valid consequence. It is akin to building a house on a foundation of sand. The structure may look impressive at first, but it is ultimately unstable and prone to collapse. Another key limitation lies in the very definition of survival within the context of quantum immortality. As we've explored, surviving a catastrophe doesn't necessarily guarantee a pleasant or even a desirable existence. You might find yourself trapped in a world of unimaginable suffering, or confined to a body that is broken and beyond repair. Would that really constitute survival in any meaningful sense? Or would it be a fate worse than death? It is like being granted a wish, only to realize that the wish has been twisted and contorted in ways you never could have imagined. The thought experiment also grapples with the issue of identity, the challenge of defining who you are in a multiverse where countless versions of yourself exist. If every choice creates a new timeline, then there are infinite versions of you making different decisions, living different lives, and experiencing different realities. Which one is the real you, and what connects them all? It's like looking into a hall of mirrors, each reflection slightly different, yet all bearing a resemblance to the original. Ultimately, quantum immortality is a philosophical exercise, a thought experiment designed to provoke thought, challenge assumptions, and explore the boundaries of human understanding. It is not a scientific prediction, nor is it a guarantee of eternal life. It is a tool for examining our beliefs about reality, consciousness, and the nature of existence. But how far can this line of reasoning actually take us? Can it offer any practical insights into our lives, or is it simply a mental game with no real-world applications? Perhaps, by continuing to explore these concepts with open minds and critical eyes, we can gain a deeper appreciation for the mysteries of the universe and a greater understanding of our place within it. But what might be some other options out there other than these theoretical, mind-bending theories? So, we have danced with the idea of dodging cosmic bullets and cheating death itself. But let's ask a more fundamental question, one that strikes at the very core of our being. If, as the many worlds interpretation suggests, there are countless copies of you scattered across infinite timelines, each living out different versions of your life, then who exactly are you? What defines your unique personal identity in this vast, branching multiverse? Are you merely one iteration of a multiverse mega-person, a single node in a sprawling network of selves? It is a philosophical conundrum that has stumped thinkers for centuries. The ancient Greek philosopher Heraclitus famously declared that no man ever steps in the same river twice, highlighting the ever-changing nature of existence. But if we extend that metaphor to the multiverse, then perhaps no version of you ever steps in the same river twice. Every decision, every choice, every quantum event creates a new fork in the road, leading to a different timeline, a different version of yourself. So, what remains constant? What ties all these disparate versions of you together? Is it your physical body, the specific arrangement of atoms that makes up your form. But our bodies are constantly changing, shedding cells, replacing molecules. The body you have today is not the same body you had 10 years ago or even 10 seconds ago. It's a dynamic, ever-evolving vessel. Perhaps it is your memories, the sum total of your experiences, your triumphs, your failures, your loves, and your losses. But memories are notoriously unreliable. They are subject to distortion, embellishment, and outright fabrication. And in a multiverse teeming with infinite possibilities, there are countless versions of you with different memories, different histories, different perspectives. What do we even do with our minds if our memories are constantly changing, and are we just remembering something else in another universe? What about your consciousness itself, that elusive sense of self-awareness that animates your being? But what is consciousness, really? Where does it come from? And how does it persist across branching universes? Is it a single unified entity or a collection of disparate experiences constantly merging and diverging? The renowned psychologist William James described consciousness as a stream of thought, a continuous flow of subjective experience. But if that stream is constantly branching, dividing, and flowing in different directions, does it still retain its integrity? Does it still constitute a single unified self? Is all this even truly you? Some philosophers argue that personal identity is an illusion, a convenient fiction that we construct to make sense of our lives. They propose that we are not single, enduring selves, but rather fluid, ever-changing collections of experiences constantly being shaped by our interactions with the world. Think of it like a kaleidoscope, with each turn creating a new and unique pattern, but still composed of the same basic elements. Does all the data swirling around mean something, even if we don't know exactly what? Perhaps we are all simply temporary manifestations of a larger, more fundamental consciousness, a cosmic ocean of awareness that expresses itself in countless different forms. We are each a wave on that ocean, a fleeting expression of its infinite potential. But when the wave crashes back into the ocean, does it retain its individual identity, or does it simply merge back into the whole, losing its sense of self in the vastness of the collective? It can leave your head spinning if you give it too much thought. In this view, the branching timelines of the multiverse are not creating separate, distinct selves, but rather exploring different facets of a single, unified consciousness. Each version of you is simply a different lens through which that consciousness is experiencing the universe. What is the true definition of consciousness? It is a mind-bending idea, one that challenges our most basic assumptions about the nature of reality and the self. But it also offers a profound sense of connection, a recognition that we are all part of something larger, something more mysterious than we can possibly imagine. It makes you wonder if our whole purpose is simply to exist and continue to pass on everything to everyone who comes after. If there is another you, what do they know? The American poet Walt Whitman captured this sentiment beautifully in his epic poem Song of Myself, declaring, "I am large, I contain multitudes." He recognized that we are not limited to a single identity, a single perspective, but rather that we are capable of embracing a vast range of experiences, emotions, and possibilities. Perhaps the key to understanding personal identity in the context of the multiverse is to embrace this multiplicity, to recognize that we are not defined by any single choice, any single experience, any single timeline. We are the sum total of all our experiences, the culmination of all our possibilities. It is a daunting, perhaps even overwhelming thought. But it is also an empowering one. It means that we are not limited by our past mistakes, that we are not defined by our present circumstances. We have the potential to change, to grow, to evolve into something new, something better. We have the power to shape our own identities, to create our own destinies. Perhaps in the end, the question of who we are is not as important as the question of who we choose to be. It is not about finding our one true self, but about creating ourselves, about embracing our infinite potential, about becoming the best version of ourselves, whatever that may be. As we move into the future, is it possible that the shifting sands of identity lead to aging? But even as we contemplate escaping global pandemics and nuclear firestorms, a chilling question remains: what about the ultimate inescapable fate of the universe itself? What happens when the very fabric of space and time unravels, when the stars fade and the cosmos descends into a state of utter darkness and cold? Could quantum immortality offer a way out even from the end of everything? Or is this where subjective survival must ultimately cease? Consider the concept of heat death, also known as the Big Freeze. It is the widely accepted theory of the universe's ultimate destiny, a scenario in which the cosmos gradually runs out of energy, eventually reaching a state of maximum entropy or disorder. Stars will burn out, galaxies will drift apart, and black holes will slowly evaporate, leaving behind a cold, dark, and lifeless void. It is a scenario so bleak, so absolute, that it challenges our very notion of existence. From a classical physics perspective, heat death is inevitable. The laws of thermodynamics dictate that entropy must always increase over time, leading eventually to a state of equilibrium where no further energy can be extracted and no further work can be done. It is like a cosmic clock winding down, its gears slowly grinding to a halt, until finally it stops ticking altogether. But what if the universe is not governed solely by classical physics? What if the principles of quantum mechanics offer a loophole, a way to circumvent the seemingly inevitable fate of heat death? Could quantum immortality, that tantalizing possibility of subjective survival, extend even to this ultimate cosmic catastrophe? Imagine a universe approaching its final moments, the stars flickering and dying, the galaxies fading into the darkness. In most timelines, consciousness ceases to exist, snuffed out by the cold, lifeless void. But what if, in at least one timeline, something extraordinary happens? What if a quantum fluctuation, an improbable burst of energy, somehow reverses the flow of entropy, creating a pocket of order and complexity in the midst of the cosmic chaos? What if this quantum anomaly creates a bubble universe, a new cosmos born from the ashes of the old? It is a wildly speculative scenario bordering on the fantastical, but the quantum immortality hypothesis suggests that your consciousness would inevitably shift to that surviving timeline experiencing the birth of a new universe from your own subjective perspective. It is like witnessing the dawn of creation, a front-row seat to the ultimate cosmic rebirth. Perhaps consciousness itself plays a role in this process, subtly influencing the quantum fabric of reality, nudging the universe towards a path of renewal rather than decay. Perhaps the very act of observation, of being aware, somehow increases the odds of a quantum fluctuation occurring, creating a pathway for consciousness to persist. It's a strange concept that we can somehow defy the odds in this great multiverse. The celebrated theoretical physicist Stephen Hawking explored similar ideas in his work on black holes, suggesting that they may not be the ultimate cosmic dead ends, but rather gateways to other universes. He proposed that information, and perhaps even consciousness, could escape from black holes through a process known as Hawking radiation, potentially seeding new universes with the building blocks of life. What will they think if they ever met us again at the beginning of time? If Hawking's theories are correct, then quantum immortality could be seen as a cosmic recycling program, ensuring that consciousness is never truly lost, but rather constantly being reborn in new and evolving universes. It is like a phoenix rising from the ashes, a symbol of eternal renewal and the enduring power of life. The possibilities are endless, the implications staggering. Could quantum immortality offer a way to cheat even the end of time itself? Or is there a limit to subjective survival, a point where even consciousness must succumb to the inevitable forces of entropy? Could it be that our consciousness is meant to merely experience what the universe has to offer and not be a permanent fixture? What happens when there is nothing else? Is that it? Or could the quantum computers hold the key to unlock infinite possibilities? Perhaps the answer lies in embracing the cyclical nature of the universe, the constant ebb and flow of creation and destruction. Perhaps death is not an end, but simply a transition, a gateway to something new, something different, something beyond our comprehension. So, will we survive in the face of any catastrophe, or are we meant to cease existing? Quantum immortality forces us to confront the deepest questions about our existence, our purpose, and our place in the grand scheme of the cosmos. It challenges us to reimagine the nature of reality, to question our assumptions about life, death, and everything in between. And as we gaze into the vast unknown, we can't help but wonder, is there a way out, even from the end of everything? The answer, perhaps, lies hidden within the quantum fabric of existence. But even as we gaze into the abyss of universal heat-death, a glimmer of hope, or perhaps a technological deus ex machina, flickers on the horizon. Could the very tools we are developing to unravel the mysteries of the quantum world, quantum computers, inadvertently provide evidence for the many worlds interpretation itself? Or even more incredibly, could they somehow allow us to harness the power of parallel universes? Imagine a machine not built of gears and levers, but of qubits, quantum bits existing in a state of superposition. Not just zeros or ones, but both simultaneously, a dizzying dance of possibilities. These qubits, entangled and interconnected, perform calculations in a way that shatters the limitations of classical computers. They explore multiple possibilities at once, like a team of mathematicians solving the same equation in different dimensions, then merging their results. But is that just a metaphor, or is there something more profound at play? Some physicists believe that the sheer power of quantum computers, their ability to perform calculations that are impossible for even the most powerful supercomputers, hints at something truly extraordinary. Could it be that they are, in some sense, tapping into the computational resources of other universes? Think of it like this. A classical computer is like a single pianist playing a complex concerto. A quantum computer, on the other hand, is like an orchestra of infinite size, each musician playing a different note, each note representing a different possible solution. But where does this infinite orchestra reside? Could it be scattered across the multiverse, its musicians playing in parallel universes, their notes somehow harmonizing to create a single coherent symphony? It sounds like something straight out of a science fiction movie. But the potential implications are staggering. If quantum computers are indeed harnessing the power of parallel universes, then their development could not only revolutionize technology but also provide concrete evidence for the many worlds interpretation. Imagine a quantum computer solving a problem that is fundamentally unsolvable by any classical computer. A problem so complex, so computationally intensive, that it would require more time than the age of the universe to solve. But the quantum computer solves it in a matter of seconds. Where did that extra computational power come from? Could it have come from other universes, from the countless parallel realities where the problem has already been solved? Some scientists are actively exploring this possibility, designing experiments to test whether quantum computers can indeed outperform classical computers in ways that can only be explained by the existence of parallel computations. They are looking for subtle signatures, telltale patterns in the data that might betray the presence of other universes. It is like searching for ghosts in a machine, listening for whispers from beyond the veil. The task is daunting, the challenge is immense, but the potential reward is nothing less than a revolution in our understanding of the universe and our place within it. Perhaps one day we will build quantum computers so powerful that they can not only solve unsolvable problems but also communicate with other universes, opening up a gateway to a multiverse of infinite possibilities. We are talking about the possibility of harnessing universes to do our bidding. What could we accomplish? What could we create? What could we fix? But even if quantum computers never provide direct evidence for the many worlds interpretation, their development is still a remarkable achievement, a testament to the ingenuity and perseverance of the human spirit. They are pushing the boundaries of technology, challenging our understanding of the fundamental laws of physics, and paving the way for a future that is beyond our wildest dreams. Are they a threat, or are they a tool for good? Perhaps in the end, the most profound lesson of quantum computers is not their ability to solve complex problems, but their ability to inspire wonder and awe, to remind us that the universe is far stranger, far more mysterious, and far more full of possibilities than we ever imagined. What if a quantum computer can tell the future, or maybe even fix the problems of the past? Will we have a utopia on our hands, or a disaster on a global scale? The answers, perhaps, lie hidden within the quantum fabric of existence, and we must explore them to see what they tell us. But as we delve deeper into the technological possibilities of harnessing parallel universes, a profound question emerges. What if the very notion of quantum immortality, this mind-bending thought experiment we've been exploring, could reshape our cultural and personal relationship with death? Could it redefine the end as we know it? For millennia, death has been the ultimate full stop, the final curtain, the great unknown that casts a long shadow over human existence. Cultures across the globe have developed elaborate rituals, beliefs, and mythologies to grapple with the inevitability of mortality. From the ancient Egyptians who meticulously prepared their pharaohs for the afterlife, to the modern-day traditions of mourning and remembrance, humanity has always sought to make sense of death, to find meaning in the face of loss. But what if the subjective experience that we call life did not truly end as we all thought? But what if quantum immortality offers a different perspective, a radical alternative to the traditional view of death? What if consciousness subjectively persists, navigating the branching timelines of the multiverse, finding a way to continue existing even after the body has ceased to function? Would mortality lose some of its finality? Would death become less of an ending and more of a transition, a doorway to another reality? It is like imagining death is nothing more than simply entering another room. Imagine a world where people genuinely believed in quantum immortality, a world where the fear of death had been diminished or even eliminated altogether. How would that change our cultural attitudes towards life and death? Would we become more reckless, more willing to take risks, knowing that we would always find a way to survive, at least from our own perspective? Would we lose our sense of urgency, our appreciation for the preciousness of each moment, if we believed that we had an infinite number of lives to live? Or could the opposite happen? Could the belief in quantum immortality actually enhance our appreciation for life, inspiring us to live more fully, to cherish our experiences, and to make the most of every moment? If we knew that our consciousness would persist, even after death, would we be more inclined to focus on personal growth, on making a positive contribution to the world, on leaving a lasting legacy that would outlive us? Maybe there is nothing more important than legacy after all. Perhaps the key lies in understanding that quantum immortality is not a guarantee of eternal bliss, but simply a possibility of continued existence. It doesn't promise a life free from suffering, hardship, or loss. It only suggests that our consciousness will find a way to persist in some form or another, in some timeline or another. The very idea that consciousness could survive the death of the physical body has been explored by countless philosophers, theologians, and spiritual leaders throughout history. From the ancient concept of reincarnation to the modern-day theories of mind-body dualism, humanity has always grappled with the question of what happens to our consciousness when we die. The renowned Swiss psychiatrist Carl Jung believed that consciousness was not limited to the physical brain, but rather connected to a collective unconscious, a shared reservoir of archetypes, symbols, and experiences that transcends individual lives. He suggested that death was not an ending, but rather a transition to a new state of consciousness, a merging with the collective unconscious. If consciousness is indeed connected to something larger than ourselves, then the possibility of quantum immortality becomes a little less far-fetched. Perhaps death is not the annihilation of consciousness, but simply a shift in perspective, a merging with the cosmic consciousness that permeates the universe. Maybe it has always been here and we are only just beginning to find out now. But even if we accept the possibility of quantum immortality, it is important to consider the ethical implications. If death loses its finality, how would that affect our attitudes towards end-of-life care, euthanasia, and the treatment of terminal illnesses? Would we be more inclined to prolong life at all costs, even if it meant prolonging suffering? Or would we be more willing to embrace death as a natural part of the life cycle, a transition to something new? The answers to these questions are complex and multifaceted, and they will likely vary depending on individual beliefs, cultural values, and personal experiences. But the very act of asking these questions can help us to reevaluate our own attitudes towards death, to confront our fears and anxieties, and to find greater meaning and purpose in our lives. Could we learn to live without the dread of death? Quantum immortality may not offer a definitive answer to the mystery of death, but it provides a powerful framework for exploring the unknown, for challenging our assumptions, and for expanding our understanding of consciousness and reality. Perhaps the ultimate transition is not a moment of fear and dread, but a moment of awe and wonder, a chance to glimpse the infinite possibilities that lie beyond the veil. What if death is more than we thought? It forces us to reflect on the ultimate questions. What is the meaning of life? What happens when we die? And what does it truly mean to be human? As the great transition is faced by each and every one of us, the very existence of our subjective awareness causes us to ponder what kind of comfort or existential dread awaits us. Even as we've taken a metaphorical stroll through existential threats of the highest order, the nagging question persists: can this thought experiment, this quantum tightrope walk, truly alter our perception of death itself? We've seen how cultures across the globe have crafted elaborate tapestries of belief to soften the blow of mortality, to find solace in the face of the inevitable. But what if quantum immortality, this audacious concept we've been dissecting, offers a dramatically different narrative? Could it be that we are all, in a sense, living multiple lives simultaneously, our consciousness flitting between timelines like a hummingbird sampling nectar? The sheer possibility transforms death from an ending, a black void of nothingness, into a mere doorway, a transition to a different state of existence, a different stage in a cosmic play. But let's not get carried away by utopian visions of eternal bliss. Quantum immortality, if it exists, is no guarantee of a comfortable afterlife, a celestial resort where we sip cocktails and bask in the glow of divine approval. It is merely a suggestion that our subjective experience will continue, that our consciousness will somehow find a way to persist, even after our physical bodies have crumbled into dust. Consider the words of the English playwright William Shakespeare, who wrote in Hamlet, "To be or not to be, that is the question." This existential pondering has been present for centuries and will continue to remain even if there is a chance to live forever, because at what cost are we willing to keep moving forward? What if that continued existence involves unimaginable suffering, an endless cycle of pain and loss? What if we are destined to witness the destruction of everything we hold dear, to wander through desolate landscapes haunted by the ghosts of our past? Is that truly a fate to be desired? Would we actively search for this immortality, or would we choose to simply let the world pass on without us? The implications of quantum immortality extend far beyond the realm of individual experience. If death loses its sting, how would that affect our societal values, our ethical principles, our relationships with one another? Would we become more reckless, more selfish, more detached from the consequences of our actions? Or would we embrace a newfound sense of responsibility, recognizing that our choices have ripple effects that extend across the multiverse, shaping the destinies of countless other versions of ourselves? Perhaps in the end, the greatest challenge of quantum immortality is not to avoid death, but to learn how to live in the face of it. It's about embracing the present moment, cherishing our relationships, and making a positive contribution to the world, regardless of what the future may hold. It's about finding meaning and purpose in a universe that is both beautiful and terrifying, both full of wonder and riddled with suffering. If we had all the time in the world, what is the first thing we would truly do? The German philosopher Friedrich Nietzsche, in his book Thus Spoke Zarathustra, spoke of the concept of eternal recurrence, the idea that we will relive our lives exactly as they are an infinite number of times. It's a challenging thought, one that forces us to confront the choices we have made, the people we have hurt, and the opportunities we have missed. What could we do better with this next chance? But Nietzsche also argued that embracing eternal recurrence can be a source of profound joy, a way to affirm our existence, to love our fate, even in the face of hardship and suffering. If we knew that we would live our lives again and again exactly as they are, would we strive to live them more fully, more authentically, more compassionately? Ultimately, the question of whether or not we will survive in the face of any catastrophe may be less important than the question of how we choose to live here and now. Are we meant to simply exist, or are we meant for something more? While definitive answers remain elusive, the thought experiment itself forces us to confront deep questions about reality, consciousness, and survival, ultimately shaping our perception of the quantum fabric of existence.